Hello, and welcome to Shane's Microscope. I'm Shane, and this is my microscope. Let's take a peek. Today's sample comes from Bird Bath B. It was recently frozen solid, and as you can see, it's still a little bit frozen, but it's thawed enough for me to collect a sample from it, and I figure that would create a new baseline from which we can watch how it evolves as the seasons change. The water in there looks almost like tea, and with all those leaves in there, I guess it kind of is, just not one you should drink. So I put some water and sediment onto a slide, pressed the cover slip down a little bit to flatten the sediment, and let's check it out. Now under the microscope, I can just barely see some really tiny dots moving around that sediment. Even at slightly higher magnification, they are super small, but there's definitely some movement. Now at high magnification, we can see we've got a couple of different types of flagellates here. Recall that flagella is Latin for whip, because they have a whip-like structure that they can corkscrew around to move and interact with their environment. Looks like we've even got a little green algae. That's of the phylum Chlorophyta. That's the Greek chloros, green, and phyton, plant. And as we continue looking around, we can see that we've got a whole variety of little flagellates, very tiny, just corkscrewing their way here and there. And as I got some light behind this piece of sediment, it looks like it was oops all algae. Here at another piece of sediment, again we can see the movement of small flagellates swimming around. And under high magnification, we can see that this piece has a little bit of green algae too, accompanying all those flagellates. I think this really cylindrical shaped one is interesting. Definitely seeing a number of those swimming around. And I think here we might have a Canadium. If you recall, that's from the Greek conus for dust, and that's a fungal spore. And maybe some kind of pollen, maybe pine pollen. And I'm not quite sure what this strange structure is. Some sort of algae. The real star of the show showed up when I was looking at this large piece of sediment. I noticed over there a familiar sight, a paratrick. Recall that's the Greek para, around, and thrix, hair, because they've got a ring of cilia. Under oblique illumination, we can really see how much it's able to stir up that water. It's got a whole swirl of particulates. Oh, it just got disturbed there, and we can see that brought an immediate halt to that particulate movement, and as soon as it gets going again, it's back to stirring up the water. Now, using oblique illumination under high magnification, we can identify this as belonging to the genus Uppercularia, which is Latin for covered by a lid. And if you look right there, it's got a vacuole that just contracted. Neat. Now back under bright field, we can get a good look at those beating cilia. really zoomed in, keep your eye on that contractile vacuole. Heh, neat. It looks like it fills that up as it's drawing things towards it, and then it occasionally contracts it in order to expel the excess water. Oh, there it goes again. I didn't notice that on the previous observations. I'm glad we had a look at birdbath B. In some ways it was similar to birdbath A, mostly small flagellates and green algae. Aside from that one piece of sediment that was pretty much all algae, there wasn't as much algae in this one, and that makes sense because there's so many leaves in there blocking out the sunlight. There also seemed to be a greater variety of flagellates and a ciliate, that paratrick, which we didn't see any of in the birdbath A sample. So it's possible the insulation provided by those leaves gave them a slightly more favorable environment to weather the hard freeze. Alright, well I think we'll leave it there for the day. Thanks for having a look with me. Until next time, keep on peeking.